regression for Psychology 355 at Liberty University. I'm Trilby Cox, and I'll be taking you through the different steps for running this test and learning how to interpret it and write the APA results section in the next presentation in this module on writing the results. So let's go ahead and look at a sample homework assignment. Here we have two sets of scores, a test anxiety score and a set of exam scores, and these are scores for the same people. So the same person has a test anxiety score and an exam score, a second person, a third person, all the way down. So as you can see, it's set up very similarly to the correlation scores that we looked at last week. So let's look at our research scenario. A psychology professor wants to determine the effect of test-related anxiety on exam scores in her class. She administers a measure on which higher scores indicate higher levels of test-related anxiety. And then after the class takes the exam, the professor records the grades out of 90 points possible next to those anxiety scores here in this table. Conduct a linear regression to determine whether test-related anxiety predicts exam grades. So the main purpose of linear regression is this prediction. Unlike correlation, where we're just looking at a relationship between variables, regression takes that one step further and says, well, can I use the scores on one variable to predict the kinds of scores that might come out on the other variable? And it uses a data set to do that and to try to describe it in a way that we'll look at when we run the test and look at the output in SPSS. So let's look at how to set up this test. First of all, you've got your data file. First are the test anxiety scores in the first column, and the second column are the exam scores. The easiest way to set this up is to put that the variable that you're using to predict with in the first column, and in the second column, put the variable that you're trying to predict, that dependent or target variable, put that in the second column. They're both scale level variables. For a linear regression, these both have to be scale. So there we've got our data set up, and let's look at how we'll run our test. So we'll go to the Analyze menu as usual, down to Regression, and then over to the second option, which is a linear. So this is our linear regression dialog box. You can see that our two variables are on the left as usual, and we're going to go over where to put these variables accurately for the test to come out correctly. Last week with correlation, it didn't matter how you arranged the variables either in the test or on the graph, but this week it will matter where you put which variable for it to come out correctly. The dependent variable is always the variable you're trying to predict. So that exam score is what we're trying to predict, so that's going to go in this dependent variable box. The independent variable here is anxiety score, because we're using those anxiety scores to predict our dependent variable. So we move that over here to this box. The only other thing you need to do here is to go into the statistics dialog box, so click the statistics button. And here you want to make sure that you've clicked estimates, confidence intervals, and 95 is fine, model fit, and descriptives. So those are four different things that you want to click to get all of the information on the output that you'll need to be able to interpret the data and write it up in your results. So we'll click continue and OK. And here is our output. Now, as you can see, it's a little longer than last week. And this week, because there's a lot of new information to go over, the APA writing presentation that goes through interpreting that output and putting it in the results section, that presentation this week is very detailed. So I'm going to briefly cover the output here, but you're definitely going to want to make sure you watch the APA style results presentation, because I go through this in more detail and I talk about how to put it all together in the results section. So that being said, let's just look really quickly at the different tables that we have. First, we have the descriptive statistics with the means and standard deviations for each set of scores as usual. Then we have our correlations. So this is the Pearson correlation like we looked at last week. This is just going to tell us whether our variables are significantly related or not, just in general. And here you can see that we have a negative correlation, but it's pretty small, negative 0.118, with that significance level, that p-value of 0.310. So greater than 0.05, so not significant in this case. We scroll down here to the model summary box, and in the model summary, there are two numbers that you want to pay attention to. The first is the R-square, which is 0.014. The second is the standard error of the estimate, which is 11.185. Now, in that presentation that I mentioned, I go into exactly what those are and how to interpret those, but those are the two things you want to look at. Here in the ANOVA table, the ANOVA is part of regression. The ANOVA is run basically to decide how well this regression analysis does predict the scores on the dependent variable of exam scores. And here we can see that our F value is 0.255 and the significance is 0.619. So again, not significant. Finally, the coefficients table. This is where we're going to get the information to write our equation of the line. If you've been doing your reading this week, you know that the central concept of linear regression involves this line that we want to kind of draw through the data. If you imagine a scatter plot, we're going to draw that line through the data, and we're going to see how well that line fits the actual data and how well you can use the equation of that line to predict the score, like the exam scores, on your dependent variable. This table coefficients gives you, in the first column here, it gives you some of the values that you'll fill into that equation. And again, the APA writing presentation goes over this in much more detail. So be sure to watch that. And the last two columns here in the coefficients table cover the 95% confidence interval. And the one that you want to pay attention to is the one on the bottom row, where it says negative 0.354 to 0.217. That's the confidence interval for the slope of our line, whether it's flat, whether it's a positive slope or a negative slope. Again, the APA writing presentation covers this in detail. But these are the main areas that you're going to want to look at on your output. So your full output should have all of these different tables of information on it if you've done it correctly. So let's go back to our data file and look at how to graph a regression. And it's very similar to what we did last week, but we're going to add one step. So in the graphs menu, I'm at legacy dialogues, and I'm going to go again down to scatter dot and a simple scatter define. And here's our dialog box. Now here, it's very important to choose the correct variable to put on the X and Y axis. So as with most of the other tests that we've been doing, you always want your dependent variable to be on the Y axis, the vertical axis on the left. Exam score is what we're trying to predict. It's the dependent variable, so it goes on the Y. Anxiety scores then go on the X axis. So this is all set up, and we want to go ahead and click OK. And here is the output, and here is our scatter plot. Now, this is the first step. You've got your scatter, you've got your dots, as you can see, kind of all over the place. And so we're going to look at how to add the regression line to this graph, and it's done right here in the output window. It's not done from the graphs menu. You have to use what's called the chart editor to be able to do this. So what you need to do, and in a lot of presentations, you've been seeing that little box click up that says double click to activate. That's what we're going to do this time for the first time in the course. Double click this box, and it opens what's called the chart editor. And the chart editor is how we're going to define our regression line and add it to the graph. So here in the chart editor, you see several different menu options, and you want to choose the one that says Elements. And under Elements, you're going to choose this option that says Fit Line at Total. Click on this. And what's going to happen is two things. You're going to have this properties box pop up, and you're going to have a line appear on your graph. You can actually just close this properties box. You don't need it, so exit out. And you can see that SPSS has added what is called the regression line, or the line of best fit that it has calculated for your data set. So again, it's great. We don't have to do this by hand. SPSS totally draws this line for you, and this is the best predictive line of exam scores based on test anxiety scores based on the data that we have. So once you've got this going on here, all you have to do is close the chart editor. You don't need to do anything else. And now in your output, your line will appear right here across the graph. And you see that rectangle in the middle where it says y equals 64.38 minus 0.07x. That is our regression equation, the equation of the line. And in the APA writing presentation, I go over this in detail. I go over what it means, what it tells us, and how to interpret it. So this is just the basic tutorial for showing you how to run the test and how to create the graph. And now you'll want to move on to that writing presentation in order to learn about how to interpret it all and how to put it all together. So thank you for joining me, and this concludes this presentation.